In part D, we have to find an expression for f inverse of x. Now, in the previous part, we found out that f of x was equals to minus 3 into x minus 2 whole squared plus 14. To find f inverse function, we'll first write y equals to minus 3 into x minus 2 whole squared plus 14. Now, exchanging the values of x and y, this will be x equals to minus 3 into y minus 2 whole squared plus 14. Making y the subject, so we can take this minus 3 and y minus 2 whole square on the left hand side, and this will be equals to 14 minus x. So this will become a plus 3 into y minus 2 whole squared. Now dividing the expression 14 minus x by 3, so this will become 14 minus x upon 3. We now will take the square root on both the sides, so this will become y minus 2 is equals to the square root of 14 minus x upon 3. Finally, taking 2 on the left hand side, right hand side, we'll get y equals to 2 plus square root of 14 minus x upon 3. As the square root sign has a plus and minus sign, so we'll add y equals to 2 plus minus square root of 14 minus x upon 3. Now, from the previous expression, we know that the value or the domain of x was x is less than or equals to 2, which means that the range for f inverse has to be also less than x less than or equals to 2. Now the expression for f inverse of x is 2 plus minus square root of 14 minus x upon 3. So if we use a positive sign, 2 plus any number will be greater than 2. But as the range of f inverse has to be less than or equals to 2, which means we cannot take the plus sign. So the expression for f inverse of x will be equals to 2 minus square root of 14 minus x upon 3. Again, just for clarity, the domain of f of x will be the range of f inverse of x. From the previous expression, the domain for f of x was x is less than or equals to 2, as we found the value of the value of x was equals to 2, which was a turning point. So as this was the domain, the range of f inverse will also be less than or equals to 2. So to keep the value less than or equals to 2, we have to add a negative sign up here, as adding a positive sign will make the range go over positive 2. In part E, the result of translating the graph y equals to f of x by minus 3 and 1 is the graph of y equals to g of x. We have to express g of x in the form px squared plus qx plus r. Now, when we're translating in the x and the y direction, so if we have a function f of x, if we translate in the x direction with a units, the function becomes x minus a. And if it is, so if we are translating it positive a, this will be x minus a. And if we are translating it minus a in the x direction, this will be written as f of x plus a. And if we are translating it in the y direction by a units, so the function f of x will become f of x plus a if we are translating it positive a in the y direction. So if you're translating f of x negative 3 units in the x direction, so the expression for f of x was minus 3 into x minus 2 whole squared plus 14. As it is a negative 3 units in the x direction, so we'll write it as minus 3 into x plus 2. So this will be x plus 3 minus 2 whole squared. So this will become x plus 3, and then the minus 2 will remain as it is, whole squared plus 14. And as we have 1 unit translation in the y direction, so 1 will be added to the complete function. Now simplifying this to get the expression for g of x, we will get minus 3 into x plus 1 whole squared plus 15. Expanding, we'll get minus 3 into x squared plus 2x plus 1 plus 15. So this will become minus 3x squared minus 6x plus minus 3 plus 15. Simplifying, the final expression for g of x will be equals to minus 3x squared minus 6x plus 12.